Classification of embedded system. Type of embedded system. There are two types of embedded systems. Main type 2 are based on performance and functional requirements, and second type, main type, is based on performance of microcontroller. So now first is based on performance and function requirements. So here real-time, stand-alone, network and mobile. So these are the four main type of the embedded systems, and here base of performance of microcontroller, depending upon the microcontroller, which kind of the microcontroller you know that there are different kind of the microcontrollers are available in the market, PIC, ARM, 7, etc. So according to that, using of the microcontroller consists of the microcontroller of that particular embedded system. They are classified small scale, medium scales and sophisticated embedded systems. Now first we will see here real-time embedded system. So real-time embedded systems are defined as those systems in which the correctness of the system depend not only on the logical results of the computation but also on the time at which the results are produced. In short, we can say that embedded system in which some specific work has to be done in the specific time period are called real-time system. Real-time system means the specific time that specific work is done, that is called as a time period based systems, or that is called as a real-time system. So real-time systems are categorized as a hard real-time system from real-time systems and soft real-time system. So hard real-time systems, what actually happen in this hard real-time system? So the example is it is example of missiles, you know that in the real-time system missing a deadline may lead to great damage. So that is the so here some timing great damage will be happens if missing the deadline. So that hard real-time times example is you know that missiles. It is the one major it could be the the major example of hard real-time system. Now real-time system, from real-time system, the banking. So you know that we credit the amount, we debit the amounts, so it must be updated real time. So there basically use the form real-time system. Now last is soft real-time system. Soft real-time system, the system tried to meet the deadline, but if fail does not causes any major damage. For example, CD player. If you play the CD player doesn't have, suppose you play the CD players, what will happen after that? Nothing. So it is continuously working. So this is the one CD player. It is the major example of the soft real-time system. Video on demand. So this is the major example of if you continuously run the CD players, what will happen? So it is continuously on. So if you stop that CD players, it will be continuously stop still. So that is soft real-time system. Try to meet the deadlines, but if fails does not causes any major damage. So now next is stand-alone embedded system. So stand-alone embedded system, here stand-alone device is able to function independently of other hardware. This means it is not integrated into the another device. It's take the input from the input ports, either analog or digital, or process, calculate and converts the data and gives the resulting data through the connected device, which either controls, drives, display and connected devices. So here, so you know that name suggests the stand-alone system work in the stand-alone mode. So they takes the input, process them, produce the desired output. The input may be electrical signal from getting from the transistor, commands, etc. So by pressing the buttons, this is it is the one signal which is getting from the external peripheral device to the embedded system. The output can be electrical signal, just like to the LCD display. We can say that as LED display for displaying the information to the users. So this is the This is called as a standalone embedded system. So what are the example of standalone embedded systems? So here digital camera, microwave oven, CD player, air conditioner or TV. TV, it is the major, it could be the major application, or we can say that the example of standalone embedded systems. You know that if you press the particular channels, it's continuously on. Okay, once you press the button, then it's continuously on. Suppose you want to turn change that particular channel, then you have to press the particular buttons, then embedded system will take the action. Without the pressing the buttons, it can't take the any action. So that it is called as a standalone embedded system. Now next is network embedded system. These types of the embedded systems are related to the network to access the resources. The connected network can be LAN, WAN or internet. The connections can be any wired or wireless. These types of the embedded system is the fastest growing area in the embedded systems applications. So network embedded system, it is sometimes called as a IoT. And now the network, suppose there are n numbers of embedded systems are connected to each other with the help of LAN, then called as a LAN network embedded system. Suppose n numbers of embedded systems are connected to each other via the WAN, then called as a WAN network embedded systems or network internet. So internet, suppose there is connected in numbers of embedded systems with each other with the help of the internet, then that called as a IoT, or it is sometimes called as a network embedded system. So what are the examples of network embedded systems? We can say that the mobile, it is the one major applications of we can network embedded system. And next, mobile embedded system. Mobile embedded systems are used in portable embedded devices like cell phone, mobile digital camera, MP3 players and personal digital assistant. The basic limitation of this device is the other resources limitation of memory. So mobile embedded systems, basically it has the one drawback. So drawback is that constraints about the memory is less along with that system. So that is the one drawback of this mobile system. But the advantage of this mobile embedded system, so size may be reduced, power may be reduced, power dissipation may be reduced in the mobile embedded system. So mobile device are considered as the embedded system. So itself, mobile or smartphones, we can say that the personal digital assistants, we can say that the mobile, they are the example of mobile embedded system. Sophisticated embedded system. So these types of the embedded systems have enormous hardware and software complexity that they may need the various we can say that configuration processor, and they are used for cutting edge application that need the hardware and software co-design and the components which have to assemble in the final system. That is called as sophisticated embedded system. Now, application of embedded system. So application of that embedded system: industrial machines, automobiles, medical equipments, camera, household application, airplane, vending machines, toy, etc. There are widely used the embedded system. So small scale embedded system and medium scale embedded system. So here, small scale embedded system, these are type of embedded systems are designed with the single 8-bit or 16-bit microcontroller that may even be activated by the battery. So small scale embedded systems, basically there is used 8-bit or the 16-bit microcontroller. So that's why it is called a small scale embedded system. And for developing the embedded software for small scale embedded system, the main programming tools are required, just like to the editors, assemble, cross compiler, cross compiler, assembler. That means it's required the integrated development the developments tools for developing the embedded software for the small scale embedded system. Now medium scale embedded systems. So here, so these types of the embedded system designed with a single or 16 or 32 bits microcontroller. So what is the basic difference between the small scale and medium scale? There, the small scale use the 8-bit or 16-bit, and the medium scales basically use 32-bit microprocessor or DSP processor are also used. These types of the embedded systems have both hardware and software complicated. For developing the embedded software for the particular applications in the medium scale embedded system, the main programming tools are required: C, C++, Java, Visual C++, RTOS, debuggers, source code, engineering tools and simulators IDE is required.